Okay, great. We're going to get started now. Welcome everyone to Always Coding, Always AI's weekly Hacky Hour. My name is Lila Mullaney, and I'm a software engineer and developer advocate with Always AI. And this week we're going to be doing thermal imaging with Steve Grisette, our CTO. So I see some familiar handles in the attendees, but for any of you who are new, this is just pretty informal weekly time we have to go over concepts and cool apps. So please always put your questions in the chat and we'll get to them. You can ask them live. We'll unmute you if that's easier. So don't hesitate to put any questions in the chat as we go. Before I hand it over to Steve, I'm going to just run down how to get started with Always AI in case anyone here is new and hasn't done that yet. So first, let me see, I'll share my screen. We're going to go to the Always AI homepage, and I'll put these links in the chat. So you want to log in to alwaysai.co. Once you're logged in, you'll see dashboard. Otherwise, you'll see a login sign up button. So once you've got your account all set up, you can go to your dashboard, and we're going to do new project. This week is all about object detection, so we're going to choose one of these templates for object detection. I'll just call it Hacky Hour, create our project. Okay, so once you get here, you can see that you can download. I'm on a Mac OS. I'll also show you after this is done how you can get to the same place from elsewhere, not just in your project dashboard. So if you haven't already installed the CLI, you're going to want to download and install that. You might get some warnings for like a security warning. It's because right now our software is unsigned. But on our doc page, there's frequently asked questions that will walk you through how to avoid all of those for Windows and Mac. And the good news is that shortly we'll have a new installer out that will avoid that. I promise it's safe already. It's just a bit of a hassle to get it signed through all the different channels, but that's coming soon. So this is just a temporary thing. So once you have your account, you have your CLI installed, and you've got a project started, you're just going to copy this command right here. We're going to go to our terminal. And then I've already navigated into a general directory that I want to use. But
Lila, we can't see your terminal.
Oh, thank you. New share. Perfect. Can you see that okay?
Yep, perfect.
Thanks, Kamal. We're going to make a directory. We'll just call it Hacky Hour. And then we're going to run this command, and that will configure our project. Yes, you could proceed with download. And I'm just going to do it on my local computer for now. And then we'll do AI app install to install our virtual environment and any models. And I have to do a new share as well because I was silly. And there we go. Now you can see we're running an object detection model. Handy. And now I'm going to pass it over to Steve, and he will show us how to do some object detection with thermal imaging.
Thanks, Lila. Hopefully somebody's going to share the slides. So
that's me. I'll do that too.
Got it. So everyone.
Thank you for the reminder.
Yep, no problem. So today we're just going to talk a little bit and do some demos and use the FLIR thermal camera. So they have a small camera called a Lepton, and we're going to be taking a look at that and how you use thermal cameras with Always AI and OpenCV and so forth. Now, what I can say is we're waiting for full integration on this. So we're taking and we're putting a Python veneer around the C libraries that they have, that the FLIR has. And so that will enable us to do the radiometry, which is where the temperatures. But today we'll just try to take a look at image detection and so forth on the FLIR camera, how to use an Always AI platform. Then the coming weeks, I'll continue to add to the Git repo, and we'll start to add those APIs into the core code. But this is basically, I'm going to go through and just show you how to use the camera. And what we'll try to do is build a thermo detector, and it should detect mammals, which I think that I'm part of based on the encyclopedia. So we'll try to detect me and maybe my computer screens because they run hot. Those that have FLIR cameras and those that want to do these projects, I think the cool part is doing them at night. So you walk right in, the camera can pick you right up and so forth. So with that, let's get started. So So number one, so the agenda, we're gonna just talk a little bit about the theory behind most thermal cameras. We'll talk about some of the applications that you can use on these thermal cameras. And then we'll just talk about, how do I get started? How do I use my FLIR development environment? What are the components? What should I use, and so forth. Then we'll get into the coding examples. So that's our agenda for today. Next slide, Lila.
Sorry, 1 second. There we go.
Okay, no, it's okay.
Not wanting to. There. There we go.
All right, so let's talk about the theory a little bit. So lights all around us, or what they call electromagnetic radiation. So, and it has the visible light spectrum on one side. We have infrared up on another spectrum side, and I put it in there that actually from 9,000 to 14,000 in the wavelength line, and then we have all the way down on the other side the ultraviolet side of the spectrum. So we see in the visible light spectrum, which is, if you look at that graph off to the side, or that image off to the side, it kind of shows you we're in a narrow bandwidth, but there's a whole world around us and so forth that's not in that. People that are into astronomy and stuff like that, some of those things are very interesting to them, those wavelengths and so forth. So what we're going to use the thermal cameras is really to punch up into that infrared range. So it's outside of the visible spectrum we want to detect. That's why I was saying at night, it's very interesting. It's good to detect people. It's also not bad during the day too, to be able to do this. There's just some filtering techniques which we'll walk through that OpenCV provides us to kind of take down some of the noise in the image itself. So let's talk a little bit about the FLIR Lepton sensor. So it's a microbolometer sensor. So what does that mean? Well, it has a sensor. It's made of a material that that can detect the heat of infrared radiation, and then it can detect what temperature it is by resistance. This material has a resistance to it. The next thing that happens is the firmware inside the device can create, using the information from that resistance, create an image. So an image that you and I can see and so forth. So some people call it a fake image, but it's an image. It's got 3 channels and everything to it. So it's really cool. The sensor can, that image then can be processed with all the techniques we know in computer vision. So that includes, OpenCV and its image manipulation piece. Let's say if you took what Lila did, was it last week or the week before? I think it was 2 weeks ago that you did the data capture piece, Lila. But if they,
I think you're right.
yeah.
I can't remember which one it
So
was.
if you captured a data set in this and so forth and use the model retraining, you could actually train it on those thermal images to pick up people or whatever other objects you want to do that are generating heat that it could pick up. So it's really cool. So again, you can use all the same type of techniques and so forth. And like I said, the radiometry libraries are coming. I think in the next 2 weeks, you'll see those into our system, and I'll go ahead and update and maybe sneak in and show how to use those on our on one of these hacky hours. So at least get a little time on it on that. So any questions thus far? I think we have one.
Yeah, AB is asking, first of all, he says, great topic. And then he asks, could you show us the hardware?
Absolutely. We're gonna, that's one of the slides coming up. We're gonna talk about that. And then if you go to the Git, AB, we also, I take you to where you can go buy that. The popular places in the United States, I know you're in Ireland, AB, so I don't know what's popular in Ireland, but FLIR does have a place for you to go get the hardware and so forth. But the popular place in the United States is something called DigiKey. And DigiKey carries a lot of electronic components and so forth you can use in your projects. Another popular place that I go to, this is my popular place. I don't know if it's popular for everybody, but there's a place called Spark Fun out of Colorado. And of course, the sparks that take off of what people that work in electronics, we actually flame our boards some of the time, and you get that little spark. Kind of a take on that. But Spark Fun's another place, and that's where these tools came today that I'm going to use, but I'll go through everything. And maybe I'll even unplug my little thermal camera and bring it up here and show you. So,
We have one voice of support for that. Both places are the go-to places for US. And we actually have one more question. Does the thermal sensor emit any type of signal to create the resistance image, or does it just receive and analyze data? And that's from Angel Burgos.
It should receive and analyze data. That's my understanding of the sensor. So if somebody knows more about it than me, then definitely I'm open to it. But that, as I understand, is that resistance material they put on the microbolometer pieces. So, and that comes from what I've read from FLIR.
Great.
On it. We ready to move, or do we still have some questions?
Okay. That answered his question.
Okay.
Cool, thanks.
Good. So let's talk about a few of the applications. I think one we can all figure out, right? So, and we see it, it's popular, night vision cameras, or, or just in general, night vision. These thermal cameras are good for. We've talked about it. You see it all over the place now in our world of COVID, right? We walk up. We had a team outing. Lila knows this happens. We walk up and they point the little thermal piece at us to get our temperature. So in medical diagnostics, you can find temperatures of different parts of the body, or in general the body. Hopefully, there's not a lot of different temperatures going on. There's one. The other things to think about is building inspection. So people like to see where they detect insulation leaks. So thermal cameras, FLIR has a big business in this, in construction, where people are going out and in the construction industry and seeing where the leaks are in their insulation. Automotive, monitoring your cooling performance and so forth. That's another one. And then where we're going to go with the technology. So, and that's what we think is exciting, is we're going to, integrate it into our tracking solution. So it's actually a pretty good tracking algorithm. So right now, and then tie it into our Centroid tracker. Right now we have one that's still in construction, but we have two trackers, right? One's a Kalman filter. It's pretty good. I think that one, Lila and Steve Batos on our team are working to get done. I don't think it's officially available, but it's on its way. And then we use a correlation tracker. And so forth. And then we have a Centroid tracker, which really is about uniqueness of an object in an image. And so we think tying this with thermal is going to be our big thing, and what we're going to work on in our own ones. And certainly if you're in robotics, that would be a good thing for tracking. And then, you could move towards a thermal source if you wanted to, if you have a robotics from a navigation system and so forth. So those are just a few of the applications that are out there. Now let's get into what AB and others want to talk to. What's the development environment all about, and things like that. So I'm going to go over, with the risk of destroying everything. Those who were with me last week know that I had my own problems, but I'm going to go ahead and kind of move over here, sorry, and I'll bring the camera over. So they really have three different, well, so first of all, you have the Lepton camera module. And that module has everything from, they now have a 2.5 version all the way up to 3.5. And it's really, the width of what you can see is the difference between the cameras and so forth. And there's a couple other takes. I'm going to use a 2.5 today. Why? Well, it was the cheapest in the catalog, but it still has power. But that's the Lepton camera modules. And like I said, again, we have within the Github, we have the resources to go out to it. Now they have a breakout board. They had a version 1, which I really liked. And you could put that on a breadboard and then hook into the GPIO connectors of either your Nano or your Raspberry Pi, or if you have other types of ARM development boards out there for the ARM 64 and 32, you could do that and had all the pins. Now, what I don't like, and this is this little guy, hopefully we can see it. Can you guys see it?
Yeah, I can see it. Maybe a little tilted.
Okay,
yeah.
There we go. Yeah. So that's it. So, and then right here is where the camera fits into this little module. This is a development board. Now, what I hate is, I'm going to go turn the light. I have the lights on. I'm going to turn the lights on so you guys can see better. Sorry. This is all part of, it's live production. As you can see, it's got these 2 rows now of pins. I hate that, because think about if you put those in a breadboard, right? The problem you're going to have as you go into a breadboard now, how do I get, it's hard to get uniqueness out of that and so forth. It gets messy. So you have to almost go to a prototyping board that you can cut and solder in and so forth. Sorry, I got to hold it up here for everyone. But this is the what we call the breakout board for it. And then I just gave you my rants and complaints on it. So on it. Probably people with better imagination and not, that want to work outside of breadboards and so forth, they can probably make it work pretty good. It's there. You can connect into the GPIO pins, and you're going to have to get some drivers from Lepton to run the Raspberry Pi and so forth and put that, or Nano, or whatever board you're using to develop on. Now the next one is, and you guys are really going to laugh at this, but okay, so I've rigged it up. So just to show you, there's my SparkFun box where the camera came into. So that's where I got it. I'm using what they call the USB module. They call it the pure thermal development environment. And it gives a USB connection into the camera. So I'm using that with the Lepton. And that's what this looks like. And yes, I mounted it in my box so it would stand up while I was doing these demos, right? And then I took a little micro USB and connected it in. So there you go. That was, what I did. But you can see it has the mounting bracket. So if you had something better than a box that it came in, you can mount your camera and so forth and use this. And then what that will do is make this show up as a USB device, which then of course makes it very easy to work with Always AI and other well, it comes up as a USB type device on it. So I think we have a question.
We do. Mahesh, and forgive me if I mispronounce your name. What are typical frame rates for such a camera, he asks?
So typical frame rates are around 26 to 30 frames per second.
Great. Thanks.
So depending on how much overhead you have. Good question on that. And we'll see that in the applications as I run them. We'll track the FPS on it. So I'm going to go hook us back. Sorry, I'm moving all over the place today, people. But I wanted you to see that.
No, that's great. It's, for me, really fun to see how things are actually set up. I think others would appreciate it as well.
Other than, don't throw the box away, I guess.
Yeah.
Here's our lessons.
The Nano does that too. It comes in the little paper box and you want to keep it.
That's right. Well, yeah, and it sits nicely in that box too. That was actually a nice construction. So let's go down the last one. So the misnomer here is a people detector. I just happen to be what I was detecting, right? And we're going to go ahead and, it'll detect wherever a heat source is. So I have a feeling the monitor I keep looking at you now, you got everybody out there in the world on, that's going to be picked up too, as well as me. I'm going to hit the lights again so we have a little darkness, so sorry, you guys are like, what's he doing today? I have a chair with rollers on it. So I think that made that very obvious, and that's what I do. I roll around my office all day. So anyway, let's go into the code actually. And so what we're going to do is I'm going to go ahead. Oh, look at that, model retraining is up to something. So let's go ahead and share my screen and tell me if you see the screen yet.
Yep. Yeah, I can see your desktop and your terminal.
There, but oh yeah, that's my that's my terminal. So anyway, so let's go up and let's go to the this is Always AI GitHub, and you can see the GitHub, /alwaysai, and I think many of you have been there. And so we have the thermal imaging repo. Sorry, I can talk. And then within there, as everyone says, I kind of gone over everything, but there's the you can go here and find out. This is where they get the getting started, where to buy things, you know, what the part numbers are for everybody that asked on it, and data sheets. So that's all up there. And then again, so what I didn't show was, you know, of course, the breakout board I went to my favorite, the pure thermal a board to go to, and then where to get that on. Yes, we talked about it, DigiKey. So there, DigiKey. So there it is right there. And then there are different components. So that's all up on the Git for you, just for those that want to know where it's at and so forth. So what we're going to do now is I'll go ahead and clone the code, and we'll go through it real quickly. And then I'm going to go in here and do my Git clone. And I don't know what. So, and that should come down fairly quickly. There's not a lot. We're not bringing a lot of this. This is our non-model day. So, okay, so the code's there. So then I'm going to go into my thermal imaging subdirectory. Okay, so now if you look at there are really 4 repositories, and we're going to go. The first one I have is just verifying a thermal camera one. So that basically is just going to come up, use our video access to webcams, and then it's going to put it up on the streamer. And we can go through the code on that. But at first, there's a bunch of other little tools I want to teach you real quick on this to test the application. So I'm going to SSH into my Pi real quick. And I just want to show you some of this because it comes up on discourse channels. So I'm going to go into it. So, and the -y means I'm going to fire up my X Windows server here on my PC. And remember, X Windows is weird. What's over on what we would consider the server, the Pi is the client. I'm running the server over on this side to get things. So let me go ahead and do that. Cool. That's a good sign. All right. So let's see. And that did not fire up my thing. That's not good. Okay. So, well, I may not be able to show you everything that I wanted to do on it. So I don't see that it started my thing. Let me try one more time on it. Usually tells me that it's forwarding. So I'm having no forwarding luck. So unless I reset this. So let's go ahead. I'm going to go ahead and reset because it doesn't take forever.
And while you do that, would it be a good time to answer a question?
Yeah, I sure would.
He also asks, are there good sources for training data for thermal sensors, or is that something that you would have to create yourself, do you think, Steve?
So I haven't looked into that. That's a great question. I imagine I'll do some searching for those repos, but I was coming at it from, hey, you can use any of our tooling. So kind of use the tooling that's up in our GitHub here that I'll go this way real quick. The image capture dashboard, if you use that with the thermal camera, I think you can create your own data sets pretty quickly on that. But one of the takeaways is we'll try to get that done. So my Pi should be able to reboot at this point in time. Yep. Thank you, Pi. And no, we're just not going to get any love. So I'll show you some of the stuff. So one of the ways that I always have trouble, and that's figuring out, you know, what my dev is, where is my camera? So on a Linux board, one of the easiest ways to do it is to install a tool set for the camera. And this is the system to do that in. You have the sudo and you get your v4l tools utilities, and you can come in and do that. And boom, there you go. And so that mine was already installed, but what you can do is you can then list devices. And the reason I put this, because when you're coding, you need to understand where that dev is. And so this is an extra crammer coming in. So then the next thing is if you put in the v4l2 control list devices, what it'll do is show you the devices that are connected. So I can see my pure thermal is sitting out on either device 1 or 2. It should be 1 today. And then I can see some of the other cameras and different systems that I have up on the thing. So like my Pi camera right here is telling me is sitting on video 0. So it's just a way when I'm coding, I like to go in and SSH into it. To make sure that I know where it is before I start coding. So that's just kind of hopefully that doesn't distract people. Now, the other thing is on the Pi thermal, and I'll put these in the chat session or we'll get them out to people, Lila, on these. The other one is it does have standard GStreamer connectivity, the thermal camera. So if you wanted to test, and I'll see what happens, I usually bring it back on an X window. I think it's probably going to tell me it can't find the source right now in this, but we'll try to do that. And yeah, no, it fired up my X windows. We're going to get to see that. So let's see where it goes. Now, can everyone see that screen? And
yep, I can see it.
I don't think it found the thermal camera. Huh, you know why? Because I probably used 0, not 1. So let me go ahead and retry that.
It's always a good
check. Well, I found out my Pi camera works. So see people,
yeah.
There we go. Now, you know, that's what I wanted to do. So
good live debugging.
Yeah. So we'll get to see, you know, we get to see the one, then hopefully we'll get this started. Now here comes this should be the thermal, although I don't see it coming through yet. Maybe I need to make sure everything's working on the thermal. I don't see it working. And that's good test too. So let me make sure it's working now. Okay, I'm gonna have to restart it because the module wasn't down. When I was playing around with it, I didn't get the module down. So you see you get live today. Let's see if it's still gonna come up. That's not a good sign for us. I think it should work. You see the light on it. Ha!
Get system clock.
Yeah, I don't. So let's hope the other one works well. Anyway, in theory, that should work. Good for the other. Let's see. Did I do device 1? I did device 1. Should come in. Let me try one more time with it. I'll go ahead and quit that session and see if it's going to pop. Huh. Okay. Sorry, people. This is turning out to be fun like last week. We had it working. I probably shouldn't have moved my rig off. So let me go. Looks like it's working. Okay, it says it has power. And all I need to do is make sure, let me make sure my module is in place. And it says my module's good. So, okay. That should work. And by the way, the nice thing about these cameras is, I'm worried now. Okay, I may have messed myself up. That's not good. That should show something. I will endeavor to persevere here, though, and see what happens. Trying to see what else I can do on this one. That's just really weird. So maybe I don't need my keyboard. Okay. Yeah, it's getting power to the thing. Hopefully the module's set correctly. All right, one last. So I'll try the program. Let's try the program. Maybe something's wrong with the driver. I don't know. But I'm going to go in and try to verify through our programming right now. And so this is pretty standard stuff. So you just come into your Always AI app configure. And then we'll go quickly through the code, and I'll show you it's a standard piece of code. I'm going to set up my system, and I'll just call this verify as my project. And then I'm going to want to use a remote device. And then I have my Pi preset up, so I'm going to use a save device, and I'm going to call this is my Pi 4 thermal. And hopefully it will work. Otherwise, Lila, we will have you entertain people or something while I make sure the mod.
Tap dance. No. I'm sure I have some.
We got Eric to do jumping jacks one time.
That's true. I was there for that one.
So anything.
I think it's always good. I mean, there's a lot of times where I can't connect to a Pi, or you can't connect to it via the configure, but then you SSH in to kind of wake it up. So some of these edge devices can be really finicky.
Right today, so never pull your thing apart. So it says create target device does not exist. That's not good. So let me see if it's going to exist. Ping.
Wesley says that this is usually how his sessions end up going. So we're all in good company here.
All right. Well, we're having fun. It should be on 18 today. And it is on 18. I don't know why it wouldn't find it. So let's go through the, I think on target, it said it found it right when I configured it.
Yeah, it said connect via SSH.
I think AB actually wants to say something. So
okay, AB.
Hey, hi, Steve. Just when you ran the list command, right? So it was giving two device options. One is video 1 and video 2.
That's true. And I think that's a good point. That question is, did it move on me? Yeah. And that you know what, AB, I'm going to open up another terminal and I'm going to give that one a try. I appreciate you saying that. That's not a bad idea on it, in which case, we need to check our code then at that point in time. So let's see what happens if I do that. So it was Pi and 192, 168. Amal's going to get me on the time if I run over too.
Yeah.
Because of this. But hopefully we'll see. This is the fun. So we'll go ahead and see if we can't test that system again. And this time, there we go.
There we go. Good job, AB.
Well, it's on video 1. It was actually the module. So gave me a choice. I was going to try it, but anyway, so that's testing the camera through the G streamer, and you can see there I am. You can see the standard one and so forth. Hi, everybody. It
looks like you were right about the monitors too.
Yeah. So you're going to get that type of functionality. You're going to get that. So, all right. So then probably if I turned on some light, you'll see even more. There might be, it's not bad. So this is, lighted room. All right. So that's standard G streamer. That's why I like that one board. We'll try quit on this.
We have a couple questions if you're okay, Steve.
Yeah, I'm okay now. I think it's going to run now.
Yeah. So first, Angel says that's a pretty good frame rate. And then he also asked, are there any specific conditions in which the thermal camera would stop working for object detection, say distance or otherwise, like a drone, for example?
So, you have to look at the camera specs. Distance always plays again, something that's far, far away. You're not going to, this particular camera is probably not sensitive enough. I'd use it more in an indoor type of situation. So it's just quality of cameras. There are different cameras that can do that. So you have to take a look at what they're going to do. Also, it's not a wide street camera. If you notice, it's about 50% on each direction. You probably want to have a larger screen width from the center. So the newer ones on the Lepton line do that. But you just really have to go find the specs of the camera you want to do, because you have that resistance material. And you want to make sure that it is, that it's sensitive in that field. So I would, that's the cautionary pieces I would put in anything. So
definitely. And then Ross asks, in your experience with the Lepton so far, does the internal temperature of the sensor itself impact the readings? Is there a calibration procedure or like a black body source?
No, so that's the great thing about this camera is the way they put the sensor together and so forth. That's why it's a little bit more on the expensive side for a camera. The camera itself will not heat up the array that's detecting the microbolometer array that's on it. So that's a good question. That's the advantage. That's one of FLIR's market advantages. And some cameras don't do that, and they do heat up. And so that's a great question.
And then one final one is from Mahesh. Having fun, some more questions. What is typical bit width of the pixels?
Oh, question. I'll have to get back on that one. I'll have to look at my spec sheet. So if you go off the Lepton spec sheets there, I'm just drawing a blank on it. I used to know that. So
good question. You can maybe that's a good one for follow-up on Discord, Mahesh.
Yeah. So let me, you know, I'd have to look at the spec sheet coming out. So I might be able to, I'll probably get that right afterwards on this on there. So now it's everything's cooperating. It's like AB came on and then just, you know, the demo gods were with him and everything else like that. Now so what, I wonder if I did something right here or wrong here. So did it? Okay. Okay. So that would get us there we go. That's the verify. So, and then we'll go through the code here. I just wanted to show you this and running on Always AI real quick and getting everything.
Sent you a smiley face for that, Steve.
Well, I thank him too, because it seems like whatever block that we had is gone now.
Yeah.
So let's go over here and still see my screen and everything. I haven't messed anybody up.
No, I can't see your screen anymore now.
Okay, that's what I thought happened. That's a good thing. So let me make sure that Always AI is working. Oh, now close. Streamer data value, frame value. Okay, so let's go through. Let me get my screen back open again. So that's weird that it stopped sharing. Anyway, let me do something real quick here before I reshare. I'm just getting ready to go into my directory. So,
and I see now a thing in the chat, the general chat, that Ross said Asimov's fourth law of robotics and tech in general, robots don't work on demo day, and then he sent a winky face. So now we're all good. But it seems like it's a fairly common problem.
Yeah, so let's go through. I may have frame value. Okay, video reads. Huh. So I had an error in my code. That's what I'm trying to hide to everybody. I made up something. So, and I'll have to fix it up and get. So anyway, so let me go ahead and, so we're still on Zoom, right, everybody?
No screen share yet.
And we'll come back to that. I don't know how I unshared, so I was just having my own great conversation.
It happens, but now we can see everything. Now we see your desktop.
So let's go through, and I'll show you how simple this is. So this is the verify camera code that we're going to run, and we have it up there. So basically, I put the FPS meter up because we want to see what our frames per second are, which we've been asked going through the application. So you guys have seen this 100 times that have been on. This is just standard webcam, and we're going to cam 1. So it's our standard streamer. And then, you know, we just let it warm up and start, and then the FPS, and then we just do a while loop and send it out to the streamer. So that's basically it. So that's like, you know, the most basic, I think, Always AI program there is, you know, have a camera, see what's in the camera and so forth. And that's what's really nice about this thermal camera, especially if you use the pure thermal USB adapter and don't have their silly breakout board kit with the two to it. But anyway, sorry, that's again me showing contempt for their breakout board. There are applications you'd want to use a breakout board for. So I don't want to, and a little running around robot would be one of them for sure. But still, I like the mounting on that one. So let's go ahead. So I did deploy right there. So we should just do a start, and I'll show you that it works. It works. And there's the streamer. Oh, didn't like one of my values. Oh, did it not? Did I not deploy this correctly? I thought I changed it. Oh, I'm having another bad day. Let me go in and see what's going on with this.
Oh, maybe it's just frame versus frame value.
No, I know. I thought I changed that in my application. So that's frame. This is verify. I thought I saved it. Let's make sure I'm in the right directory. Oh, may not be in the right. I'm not in the, I changed another one. So the good news is it's fixed now when I push back up to get for those who didn't do it. So I'm going to go ahead and do a new window here. This is Adam, in case you guys didn't know which ID.
I actually didn't know. It looked really similar to VS Code, but not quite.
I'm going to go ahead and go into this, and then I put it into Always AI Hacky, and I'm going to go into my thermal imaging, and I'm going to open it. So now I have the right directory, and then what I want to do is make sure this is all correct here. I hate this thing sometimes. I want to get rid of it. No, that's the wrong one. Just make sure this is this. Okay, now I messed up. We're going to do it one last time. Sorry, I should have had this all open beforehand. So I'm going to, why don't we reopen a project? How about that? Yep. And then this is what I wanted to get rid of and I was having problems with. So let's go into this and then let's check our app and see that this should be frame. That's my problem. I made up something. So I have no idea why you would do that. It also shows that I had faith as a coding strategy, right? Because I didn't check that code.
Yeah.
So it will be right up in get. And I'll come back. So thank you everyone for your patience. So again, we've got don't freak out on the application has no models because it doesn't have a model today. And then we'll come into the start. And now this should work. Please work. Hit save.
I know the first time I do a new app, it always takes like probably 10 seconds for that info to appear.
No, it's okay. It's okay. Steve just panicked for some reason. It's a failure. So let's go. That's again, you guys are going to say, well, but that's it in the Always AI. So it will work completely with the streamer and everything else like that. That's it. So the next thing I want to do in the detector is really get an edge around the image. And then, like I said, as I go forward, once I have the edge in future ones, I'll be able to get the temperature range within that edge system and so forth. So what I wanted to do was the next thing I'm going to do.
Real quick before you move on, AB has his hand up. So AB, are you able to unmute yourself now?
Yeah, no. I was just saying that I really get scared when my code compiles or runs for the first time. So I'm gonna break very badly.
You're a very kind person. I just should not have. I should have ran the check on that one. So
no, but if it runs for the first time, I really suspect that something is gonna break very bad. Like
so yeah. No, I guarantee the other code I've definitely checked. I think I shouldn't say that. I believe I ran them all last night and they worked. So on that. So this one, so what I wanted to do was go ahead and start to take a look at so remember a couple weeks ago, we did the hand detection and everything. We moved over into HSV spectrum or what do I want to call it? Image analysis that OpenCV has. And so anyway, and we'll talk a little bit. So what I wanted to do here is come out of the RGB spectrum, which is what that image actually is throwing up, that we saw from the camera, then move it over to the HSV spectrum and so forth. So interesting enough, we may be able to run an object detector beam but we'll see what happens on that. So we might just run a generic one. I didn't think of that does have the 3 channels in it. But anyway, I want to get it over to HSV. And if you remember what HSV was, it's hue. That's where the color is. Saturation, how much light is in it. And V is the value, how much black is in this, so forth. So I wanted to see what it looked like in that spectrum. So to see if I could start doing edge detection using some standard techniques. So this next one is what I'm doing here is I'm just getting in on the frame value. Well, first I converted over to an HSV frame from the standard capture we have. Then I'm moving it over into just the value side of the frame. That's the frame value that somehow ended up in the last application. But
I always do that if I'm doing different versions.
I'm only looking at the value section of this. So I wanted to see what that looked like. So what happens in that spectrum? And again, usually blur to black and white, but I wanted to blur it this, or I wanted to change it down into a black and white spectrum using the value channel in HSV. So, and why do I want to, it's just I figured it would be a nice way to operate it and run standard techniques against it. So I've had success with this. This is just based on an experience curve that I've had. So I have good success with it as I try to find edges. So that's what prompted me to do it. So I'll go ahead and install, and then we'll go ahead and run this, and we'll actually type it in correctly. All right, this one should have, so nope, now it's telling me that the camera, CS camera is not there. Boy, I'm having some fun. I'm glad that, next week, guys, I'm being fired, so that's okay. Hacky Hour. So I think we have cam 1, should be there. I've never had this one happen, so let me see once more what it is. Are you guys okay? You're all plugged in? Never had that type of problem before. Yeah, make sure the camera's plugged in. Good thing I think that I still have this guy up. Let's see if it's still there. Yeah, it's still there. So, okay, so let me make sure that we had cam 1 in there. Looks good. I will try again. So let me go ahead and do an app install. Make sure I'm in HSV. I should not be having this type of problem. So that, it does not like it for some reason. So that's cam equals 1. Videos.
Are you running it on the Pi or running on a Mac?
I should. Oh, you know what? AB, you solved the day again. So thank you. No, actually, this won't help.
No, you need to configure,
yeah.
Right?
Yep. So that's thank you, AB. I need you every week. I really do. So yes, so you have to create a project. So now everyone's totally confused that it's their first time. If they're not, they're used to working with me. And we're just going to call this HSV. He's right. Now you configure it, and you're going to say use remote device.
I didn't even think of that.
And then we're going to use the save device. And guess what? I think the next time I run this program, or the next time we do the next one, we'll get it correct again. It's been a lot of fun here. So.
But this is also good. This is, it's good to have these troubleshooting, especially when you have AB to think of what the problem is, because I run into these problems and it takes me a lot longer to figure out that I forgot to configure the directory or something like that.
Yeah, you're a very nice person.
No. No, no one ever is watching me when I'm doing it, but I promise it happens a lot. And this is good. Next time somebody's using cam 0 or cam 1, or they're switching between their local and their Pi, they'll remember these things.
Yeah. And then, but I did show them that you shouldn't have that problem. So this is it coming through the HSV, and I just wanted to see what the image looks like and so forth in that. So you can see this is another way to detect, and it's in the black and white spectrum coming through. So there you go, kind of that. It's just an interesting thing. And so what this will allow us to do, if those have worked with OpenCV techniques, what you'll be able to do then, and what we're going to show, is you'll be able to use a canny edge detector against this in the space. So then you could start to get the outline of where the person's at. So that's the next phase at building the detector. So then I want to run an edge detector against it. So that's simply, like I said, that's kind of from my experience that I don't have to always go over and do a black and white. I can use HSV and then go into that value channel. And I just found more luck at using that on the different traditional detectors on it. So that's where that came from. So let's go into the next one that I promised to configure correctly. We're going to then turn loose our canny edge detector from OpenCV. and let it start to pick up some edges. So we'll go in and let's take a look at the code before we do all the configuration. So this is the next step, is really detecting the edges. So, you know, same type of thing, reversing out into the value side of the HSV. Then we're going to just kind of even out what's going on in the frame, and we're going to use a bilateral filter, and all of that is kind of a blur. So it blurs the image a little bit, which helps in the detection and in the edge detection. So I blur it and on the brightness, so we kind of get an even brightness across the system. I put the thresh here, so if you don't like what the thresh is doing, you can adjust it up and down in the canny detector. And then that's the algorithm it's using, the canny's using in it to do it. So we're going to blur and the thresh and so forth. And that should start to give us edges in that image and so forth. So then we can start to see where the edges are. And the idea is just kind of, you know, I don't have bounding boxes, right? So I'm going to try to bound this image as it comes in, and it's a detector. So let's go into this. We're now in the thermal edges. So as I've been trained by AB, I'm going to configure this application, because otherwise we're going nowhere on this. So I'm going to come in and get in a lot of projects. I'm going to create, and I'm going to call this, let's just call it edges. Get the edges.
Just a couple questions when you're ready then. He says, he asks, do you lose the depth information by converting to HSV?
The answer is, so there is no depth information in this.
So it's not, it's not a depth camera. I wonder, I don't know if you want to clarify any more, Mish, you can type another question or raise your hand.
But obviously I lose two channels. Like I lose the color channel, and I lose the saturation of those. So I lose the hue and saturation channel.
Gotcha. And then he also says, I guess, am I correct to assume that by using the edge detector on the HSV, you do not need to use thermal image-based data sets?
Well, if you're doing model retraining, yes, you do. But on this one, it's still pulling through a thermal image, and I'm using that type of thing. And this will pick up, like I said, if it was absolutely dark, it would pick it up. So that's the good news. So I don't know if that answers this question on it. So there's not a depth stream, or there's not a.
Right. He said.
But there is a thermal.
The color information from thermal could be used to estimate depth. I think it's really the thermal is like how hot something is. It happens to be kind of like centered in your core, but that's because your core is very hot and your extremities get a little cooler.
Yeah, that's right. So this is more about heat than it is about, and I'm sure that there's probably some techniques that I'll learn over time that I don't know, maybe by the sensor could be used for heat and as it moves. I know that depth cameras use infrared when they go into the point cloud. So I'm sure what's being said is true. I would just need I've always thought of depth cameras in the stereo sense, but I know like the real sense can pop over and you use thermal imaging with the stereo camera to get you what they call point cloud. So you get your XYZ, so you're floating in 3 dimensions. So that could be where it's going. So in the case of, if I did this on a real sense camera and I was looking for, and somehow this was tied to the thermal stream, I would definitely mess up distance. So I'm cutting data.
AB has typed in a data set. AB, did you want to say anything about that data set real quick, or?
No, this is just a link of some data sets.
Just a link to
just one
in thermal imaging data set you found.
Yeah, and there was a link which I was working on a solution for simple solution when COVID was thing and everybody was putting in a lot of effort to make the COVID detector. So I did not have the FLIR camera myself. So, but I found out through a contact, I got a data set. I'm just trying to look whether it's there somewhere in my other PC. But there's a data set available with FLIR, which shows the temperature as well. of the people. So yeah,
That's
that
cool.
is there. It is there. So let me have a look. I want to see whether it can be shared as well, because I'm not sure whether it's private, because it came through some private sources. Let me check. And if it's
Gotcha.
there, if it is public, definitely I will share it on Discord. Okay.
Yeah, yeah. Or you can also post it in the chat here if that's easier, and I can post it on Discord.
So
yeah.
Okay. So here we go, guys. Here's the candy detector at work. So you can see now I got me outlined a little bit. Now I can go over. Yeah, that funny looking thing is me.
That's cool.
So that's how I'm trying to put a bounding box. That's my laptop. I think well, that's my laptop over here. Some type of lighting. I'll turn the lighting down too. Like I said, it's absolutely great in the dark. So here I come back in. You still have some noise, some thermal noise now, but that's let me go over the camera. That's me. So there you go. So that's using the candy edge detector. And so forth. So that will allow me, hopefully, if I do everything right, and I'm going to use some eroding and so forth coming up to get it, and then I'm going to overlay it with the original frame, and that's how we're going to get our bounding box, and we'll do that in the next one. So anyway, that's it. So it's me on the thing. I guess if I could move this around a little bit, over here. Here I am standing back in my stuff, and that's just some lights coming in. I guess if I shut the door a little bit, maybe that'll get rid of, I don't know what that, there's definitely some heat waves coming across, but there I am. So, hey, hi, everybody. So.
Very cool. I like the heat wave bounding.
Yeah, so you have some noise back there, but from the heat. So that's cool. So then the next thing we want to do, if there's any questions on that, hopefully closed.
Oh, I think AB just posted one final link, so thank you, and I'll post that in the chat in case people want it, and I can put that on Discord later.
Yeah, that'll be good. And then, like I said, we still owe some camera specs and things like that, and I'll put those out on Discord too, on it, and so forth. So the last step is, let's combine everything we did. Let's use the heat sensor, and then let's use the edge detector and come across and see if we can frame the person, put edges around the mammal it detects, which is me, and so forth. So we're just building on the next level of that code. And, we kind of left here with the thing. The next thing I wanted to do was put a mask, and I'm going to use that mask. Of course, where I'm going to with that mask is I'm going to use the mask to overlay onto the initial image. So we're going to use that as a kind of a scalar across the original image at the end. So I come back in, and this is common when you do overlays, you create a mask. So using threshold to create the mask. And then, Lila taught us all this thing of getting rid of some of the edges and smoothing them out when she did her green screen application. So as she steals from Eric, I steal from her. So the next thing I want to do is just erode away some of the blobs of ones, so we know how we saw that thing hanging out there and so forth. So start to kind of smooth out some of the system. So I wrote it, and then I want to make sure that the mask is up to the right size. So I dilate it. And again, if you want to know details about this, Lila, this is what you did on your green screen, right? For the edges. So it's just, this is
I don't think we've done that one in Hacky Hour yet, actually, but
oh.
It's up on the blog. I'll post a link to the blog. Yeah, maybe if we get stuck for content later on.
So what Lila used it for originally, and it's something to take a look at on getting the edges cleaned up and so forth. If you do semantic segmentation, and I believe that's what Lila, you applied it to, is on semantic segmentation, it'll clean up the images really nicely and so forth. So what I'm doing is looking for some cleaning. And again, I put all the components out here so that you can play with them and over time and tune it. And then here comes the fun part. So what I'm going to do here is I'm going to convert my everything to gray and get the mask and edge. And then what I'm actually doing is I'm placing my mask and everything over the top of my frame in the streamer. I know that looks really, really ugly and so forth. And these are standard OpenCV. So I'm going to convert my color to color. And then, so I'm going back and I'm adding channels, and then I'm going to take those and I'm going to lay them on top of my frame. And then what that should do is give us an edges on top of the frame. So lots of fun here on that. So it's just like putting a scalar over a set of matrices. So so anyway, let me kind of show you what this. So this is bringing everything back, a little cleaning and putting a mask over the current one from where we were. So let me go into thermal detector. There we go. Thermal and then detector. And per AP, it's always good to AB, excuse me. It's always good to configure your system. So we'll do that. And we'll create a new project and we'll call this thermal, because we have all kinds of detectors. So I'm going to call this thermal detector. All right, and then we're going to use the remote device again. And by the way, you could with that rig that I was using, the pure thermal, you could hook it up to your PC too. So there's no reason you can't use it on your PC. And so then we'll go down to the Pi thermal. I think we have to, did we do an install? No, we did not do an install yet. Lost my track. So right now, for those, we're copying over stuff. We're building our Docker image. We've got everything going on. And then what we're going to do is take a look at our finished product. So this is a image detector, and it should have a pretty good frame of me. Of course, like you said, I can always adjust, and you may need to adjust to some lighting situations. So far, I haven't really. But let's go in and take a look at it. So we have it. And so now you can kind of tell, well, you do see my light, the light's still hot. But you see the frame around me now? So you have it framed inside.
Yeah, the white edges.
Yeah, the white edges. So there I am. Hey, here's, doesn't
Very
get
cool.
I'm not sure why, but I'll have to work on
Yeah.
that. If I bring it back, I think it should do some edges on the monitor too. So there's the monitor.
Yep, definitely.
So then the idea is then you can go internal to those, and then you can get the temperatures, which is the next step when I get the radiometry data and work out those pieces on it. But that's really what I wanted to show you. Here I am again, you know. Hey.
Yeah, AB says very cool. Angel says that's awesome.
That's a thermal camera and kind of a lightweight image detector on it. So that's what I had for everybody today. Sorry about, once again, Steve had some fun getting things done, but do we have any types of questions on that?
Yeah, no, I think it was great. I think it's actually useful to see that kind of live debugging, because it's going to come up when you're using our platform and all these edge devices. So it's always good.
Yeah. Sorry, Lila, the last thing I wanted to do, and I shouldn't stop sharing my screen. So let me reshare on it. So somebody wanted to ask the question, what's the frame rate coming out? And this is out of a Pi going across the Wi-Fi and everything. The application framework to do all that, the edge detection, everything, was almost 26 frames per second. So that's why I said this is going to be really cool when we get it into tracking and so forth, because you use your detector to find it, and then you can start to track through the with thermal. So this is what's really cool, I think, about thermal. So anyway.
Yes. Yeah, Eric says cool. He's always wanted to have an IR camera. And AB is asking how we get the temperature data. Sorry if he's missed it, if you told us before.
I haven't integrated it in. It's C types. I've got to put a Python veneer on it and everything. So I'm still working through how to do that. I ran out of time, AB. So what I'm going to do is come back and continue to add to the Git. And I will go ahead and at a future Hacky Hour within the next 2 weeks. I know we're going to do a lot of model retraining the next two weeks, but one of those I'm going to say, hey, before you do that, let me kind of show you go back to the thermal camera, and I'll get the data in on that. So I know that's what people really want because of COVID. It's a big deal on that. But So I just decided to do an image detector today until I get that all worked out on the library.
It's a cool first half, and then they'll have to come back for all the other stuff.
Yeah.
We'll just reel them in. Yeah, definitely. And Dale's saying with OpenNCC infrared plus, you can merge IR with RGB. That's very cool.
So that's really, as we get some of the iCloud devices that Dell's going to ship, we're going to come back and have like iCloud. We're going to show that as a, what do we call it, an appliance type operation, because they have a complete system. We're going to introduce people to that coming up, the iCloud AI appliance, and it will have an ARM board on it. It'll have the complete thing. The other one we hope to get from Dell is the higher end one that has the infrared, because that's going to be really cool too. And I'm getting excited about that one. So we'll probably just come back into camera land again once we get those up and running. And I think that will be really exciting. But IR is really a great thing. I'm very excited about it. I had a lot of fun working on it this week. I'm not quite complete, but I really enjoyed it.
Yeah, it was cool. And one more time, I think AB had his hand up before we go. Did you want to say one more thing, AB?
Yeah. So IR is really interesting. I agree totally to Steve. But the thing is, only the cost, like the cost of the cameras is really expensive. Like a poor man's solution. I had to build a thermometer. So I used embedded IR. It was not using camera, but it was using this MLX 90614. And just hooked up to the microcontroller to get the temperature data. But yeah, this FLIR is really cool. Just if you have some somewhere in the use case in the corporate, we can definitely get it. But for a personal hobbyist, it's little expensive. That's the thing.
Yeah, it definitely is. But as people move from the hobbyist side, AB and so forth, I really these cameras are really cool to use in a commercial setting.
Absolutely, can't agree more. Yeah, absolutely. Yeah.
There's just so much fun you can do with them.
No, FLIR is great. Yeah. We used it for a car. We did not use the IR one. We used the one which we used to create a 360 view for our project. We built a car for a full 360 view through a tele operation use case. And FLIR SDK, I think it is called Spinnaker SDK or something.
Yes,
that's correct. It's based on C++. And it's pretty good. Yeah, we could write a lot of things using that. It was very good.
Yeah. But again,
thanks, Steve.
Yeah, sure. And we'll look at getting tracking. Again, we'll show you the iCloud stuff as it comes out, and we'll continue to evolve this. But sometimes when you're working with something, it's just a lot of fun. So I had a lot of fun this week. So
yeah, this was really great. This was a lot of fun. And like you said, coming up, we'll do some model retraining hacky hours. And I did post some GitHub links for that semantic smoothing that Steve was talking about. And if you go to GitHub in general and you just look for the Always AI Git repo, we have tons, the code from this hacky hours on it, but also tons of other starter apps and other cool examples that you guys can clone and change. And then the Discord links are in there as well. And this will all be recorded and sent out on the next hacky hour and posted on Discord. So.
Yeah. And then just to say, David D, I'm reading through your project. I'll have some thoughts on it and so forth. I have you up on Discord. I haven't forgotten about you. So I just wanted you to see you out there and just say that I am going to, I think it's a great project, and I'll have some comments on it too. So I love what you're doing. So.
Yeah. Great. So I think that's it. We are ready to wrap up and see you guys next week for Hacky Hour. And thanks so much for joining us.
That one will be on model retraining.
Yes, that one and the week after will be on model retraining. And we'll send some more info out about what will be specifically in there coming up soon.
It'll be really professional next week.
Yeah. We're always super professional. Yes.
All right. Thank you, Lila. Thank you,
guys.
Bye.
Bye.